Good afternoon, everyone. You are welcome to my YouTube channel, The Don's Consult, and we are still on this FCT ERC mock exams. And the last video, I gave you the analysis, and I told you that I will go ahead to make some research and possibly come with questions. And I've done that, and we are here. I want you to check something. This was like what we did the last one, that has a pale yellow, and this another one, and this has a colorless filtrate. Now we have two types of salts here. This is a copper carbonate, you can see, but this copper carbonate has water of crystallization. You can see about has some water of crystallization. So, and it is this salt with the sodium sulfate that gave this yellow precipitate. And from research and further inquiry from other professionals, we came to a conclusion that it should be colorless. So that led to getting another salt, and this is another copper carbonate which I used with the sodium sulfate, which gave me this colorless filtrate. So I'm going to work on this now and see if the results we have will tally with some of the ones we had. So the only thing you will change here is that when you have the sample plus distilled water, they may give you the volume of distilled water. It could be 5 cm cube, it could be 10 cm cube. So when you have the volume of the distilled water and you mix it, okay, then you take that will be under your test. Sample C, sample D, or whatever sample it is in your question, plus distilled water, and then you filter. That will be your test. Then under observation, you are going to have soluble filtrate and which is colorless, and you will have greenish blue residue, as you can see here, greenish blue residue. All right. Then under your inference, you will have it as the sample. If it is C or D, says the salt is what is a mixture of soluble and insoluble salts. Okay, so now the next thing, possibly what we are projecting, they may ask you to test the sample C with a filter paper. They may ask you to test the filtrate with filter paper. You know that when you are working with filter paper, you make it damp. So let's use this and see. All right. So when we test with filter paper, there is no action. All right, no action on filter paper. And when there is no action on filter paper, you say no effect on filter paper. That will be your observation. And under inference, you say filtrate is neutral. All right. Okay. Now, should the question also now say you should divide the filtrate into portion? It could be 2 portions, it could be 3, whatever they say. Just take small portion of it. All right. Take small portion, quantity that will be enough for you to do your analysis. I think this portion is enough. So this portion now, if they say you should add barium chloride to it, of course this is my barium chloride, your table reagent, which will be provided for you. Then you put it in drop first and observe what will happen. Okay, so let's put barium chloride and see. All right, so what is this? We observe a white precipitate, all right, so you record it under the test: filtrate plus barium chloride, white precipitate. Okay, the question can go further to say add dilute hydrochloric acid. This is my dilute hydrochloric acid. Add dilute hydrochloric acid. All right, so you add little portion of that too. So when you add, you observed. All right, so you can see that's a gas. You can see effervescence. That's effervescence. That's a gas. You can see the bubbles. All right. Don't pour that much because of your hand. Okay, so you record that. That would be what? That's to tell you that we have what is it called? CO3 2 minus, SO3 2 minus, or SO4 2 minus present. Then with that dilute HCl, HCl we added, that confirms that the salt contains SO4. Just write SO4 2 minus confirmed. All right. SO42 minus confirmed. So the next thing you could be asked to have the distilled what is it called, the residue. So you take your spatula and take few collection of that, of the residue, just small as you can gather, small residue. Okay, this residue is not residuing, so you just get some. All right. Okay, so you just have to add little, add dilute what, HCl. Just add dilute HCl to it. Let's see what happened. Okay, let me take just dilute residue, add the residue, let it fall inside so that it can give you what you need. So far I couldn't go, which should have gone, so make sure that the dilute acid touches it. All right, you see what I'm doing? So let's see. All right, so this there should be effervescence formed, and that confirms the presence of CO2 gas. There should be effervescence formed to confirm the presence of CO2 gas. All right. Okay. So that will be you just write effervescence, tasteless, odorless gas. Okay. Confirming the presence of CO2, and it's tasteless, of course, but you don't need to write that. Okay. Then write under your observation, colorless, effervescence, first say effervescence occur, then colorless and odorless gas. Okay, and which turns blue litmus paper red and lime water milky. Okay, then under your inference, that is CO2 gas. Now the next one, you could also be asked to take some portion of that of the residue and add maybe sodium hydroxide in drops, then in excess. I want to go inside now so that it will help to get the correct analysis. Okay, sodium hydroxide. Where's my sodium hydroxide? Okay, this is my sodium hydroxide. You put in drops, then in excess. Let's see. We're expected to see a blue gelatinous precipitate. Let's see if it will come. Alright, yes. Then in excess, can you see? It's a blue gelatinous precipitate. Okay. Alright, so you write under your observation, blue gelatinous precipitate, insoluble in, you can see it's insoluble in sodium hydroxide, or insoluble in excess sodium hydroxide. Alright, and that under the inference Cu2 present. Alright. You can also be asked, depending on how the question goes, you can also be asked to take the the residue and add dilute ammonia. So if you're asked to add dilute ammonia, so you're expected to, so you have your ammonia, at least that's to confirm the presence of that. So let's add ammonia. This is ammonia. So you can see deep blue. Wow. So what you write, you say blue gelatinous precipitate in excess to give a deep blue solution, and under your ammonia, under your inference, you put Cu2 plus presence, Cu2 plus confirmed. All right. So this is the analysis. I'm going to write it out and also paste it for you to see. Okay, this is how far we can go to help you study it and expect the best tomorrow. If you have not subscribed, please do subscribe and have a better result for yourselves. Don Consult is here to make chemistry very simple and for your betterness. Thank you.